This is block 1 of topic 8. In this lesson, we're going to review the terms incenter and circumcenter that we learned in topic 1. We're also going to develop justifications for each one of these centers and explore the intersection of the medians of a triangle as well. You will need 7 pieces of patty paper for today's notes and assignment. You will also need a ruler. So you can use your compass that we gave you. It has a ruler along the side of it, or if you have an actual ruler, you can use that as well. So if you remember, we learned what it means to have a point of concurrency. That only happens when you have 3 or more lines that intersect at a single point. So this figure here on the left, these 3 lines intersect at a single point. And so we create a point of concurrency where they intersect. These 3 lines do not intersect at a single point, so we would not call them concurrent. We learned 2 points called the incenter and circumcenter, and those are both examples of points of concurrency because they are formed when you have 3 lines that are intersecting at a single point. So we're going to review on this animation what we learned in topic 1 about the incenter and the circumcenter. So in this triangle JKL, we are going to locate the angle bisectors for each one of those angles. I can tell these are angle bisectors by these arcs in each one of the angles, showing that it's creating congruent parts. So we have the angle bisector of angle J, the angle bisector of angle K, and the angle bisector of angle L. They all intersect at point I, and remember that is called the incenter. The incenter is the center of the inscribed circle, that's the circle inside the triangle, and the incenter is equidistant from all 3 sides of the triangle. So that is a review over what we learned about the incenter. The incenter is always inside the triangle, regardless of what type of triangle it is. The next thing we learned was the circumcenter. So we have triangle PNK that we're going to locate the 3 perpendicular bisectors of. So you can see the right angles that are created with these segments and the fact that it's bisecting it by the tick marks that are shown here. So remember, we know each one of these points is the midpoint of that side of the triangle. The 3 perpendicular bisectors intersect at the circumcenter. So point C is the circumcenter of that triangle. It is the center of the circumscribed circle that goes through all 3 vertices of the triangle. And so remember, the circumcenter is equidistant from all 3 vertices. Incenter is equidistant from the sides. Circumcenter is equidistant from the vertices. Now, the circumcenter is sometimes inside the triangle, sometimes it's on the triangle, and sometimes it's outside. So if you have an acute triangle, it's inside. If you have a right triangle, it's on the midpoint of the hypotenuse. And if it's an obtuse triangle, it is outside the triangle. So again, that is a review over what we learned in topic 1. So let's look at questions 1 through 4 on our notes, which are again a review. It says fill in the blanks with either incenter or circumcenter. So number 1, the point where the triangle's 3 angle bisectors intersect is called the, and I underlined the first letter of angle bisectors, which remember starts with a vowel, and we remember that we match vowel to vowel. So the angle bisectors intersect at the incenter. The point where the 3 perpendicular bisectors intersect of the triangle is called the, that starts with consonant. We match it with consonant. It matches the circumcenter. So angle bisectors intersect at the incenter, perpendicular bisectors intersect at the circumcenter. Which one is the point that is the same distance from all 3 sides? Remember, the incenter is the center of the inscribed triangle and it touches all 3 sides. So it's the incenter that is equidistant from the sides. So which one is the point that's the same distance from all the vertices? Remember, the circumcenter is the center of the circumscribed circle, which go through all 3 vertices. So it's the circumcenter, which is equidistant from the vertices. So we're going to learn some new points of concurrency, and that is going to require us to learn two different types of lines that we associate with triangles. So we've learned about angle bisectors and perpendicular bisectors. There's another segment in a triangle called the altitude. And altitude is a segment that always starts at one of your vertices and is perpendicular to the opposite side. So here, segment AK is an altitude of triangle ABC because it starts at a vertex and is perpendicular to the opposite side. Now, it is not a perpendicular bisector, so we do not know that CK and KB are congruent. That is not what an altitude does. It just goes from vertex and is perpendicular to the opposite side. It is the segment that you would use to represent the height of the triangle. Now, every triangle will have three altitudes. We could draw an altitude from vertex C that's perpendicular to the opposite side, and we could draw one from vertex B perpendicular to the opposite side. This is just one of the altitudes of that triangle. An altitude can be outside the triangle. So for instance, in this triangle, it's an obtuse triangle. So if I try to draw the altitude from point S, from vertex S, that's perpendicular to the opposite side, I couldn't do so and stay inside the triangle. I would have to extend out that side in order to create that 90-degree relationship. So in this case, altitude SE is outside the triangle, but it still starts at the vertex and it's perpendicular to the opposite side. We are going to focus on the median today. A median is another segment associated with triangles. It is a line or a part of a line, and it also starts at a vertex, and then it goes to the midpoint of the opposite side. So here is an example of a median. It starts at one of the vertices of the triangle, vertex N, and goes to the midpoint of the opposite side. Now, it's not a perpendicular bisector. It's not creating a right angle relationship here. It's only going to the midpoint, so it's bisecting that side. But it doesn't create the perpendicular relationship. Now, questions 7 and 8 in your notes, you have here the definition of an altitude and the definition of a median. Again, all triangles would have 3 altitudes and 3 medians. I could draw a median from point M that goes to the midpoint of this side, and from O that goes to the midpoint of this side. Here is some important information about the medians. The 3 medians of a triangle intersect at a point that is called the centroid. Centroid. Again, I want you to notice that median starts with a consonant, and so does centroid. So we have perpendicular bisector that goes with circumcenter, and median that goes with centroid. Another important fact about the centroid is the centroid is always inside the triangle. So remember, the incenter is always inside, and now we're learning the centroid is always inside. Remember, the perpendicular bisectors intersect at the circumcenter, and that can be inside on or outside. But the centroid and the incenter always are inside. Lots of things to study and remember. Now we're going to learn how to fold the centroid of a triangle. So again, I told you you're going to need 7 sheets of patty paper. We're only going to need 1 for the notes, and then you'll need the remaining ones for your homework. And then you'll need to save those for the next lesson as well. So you have a triangle that is on your notes here. And we're going to classify that triangle. Remember, we can classify it by its sides and by its angles. So if you were to measure each one of these sides, you would see that all 3 of them have a different side length. And so remember, if all 3 sides are different, it is called a scalene triangle. The angles, none of them are right angles and none of them are obtuse, so they're all less than 90 degrees. So remember, we classify that as an acute triangle. So this is an acute, I guess it really should say an acute scalene triangle. And so that's what it says, scaling acute scaling, same thing. So what you're going to do with this triangle is you're going to use one of your 7 sheets of patty paper and you're going to trace this triangle. And so you can pause this video now and go ahead and trace that triangle. So what we're going to do is we are going to fold the centroid by folding the 3 medians of the triangle. And so I'm going to get rid of the notes underneath here so you can focus on my patty paper. So to draw a median, remember we want to start at a vertex and go to the midpoint of the opposite side. So to locate the midpoint of the opposite side, we're going to do the fold that we would use for a perpendicular bisector. But we don't want the entire perpendicular bisector. We're just using that fold to locate the median. So remember, the perpendicular bisector is a point-to-point fold. So I'm going to fold point A on top of point B. So A on top of B. Now I'm not going to crease the entire perpendicular bisector. It's fine if you do so. You just don't need that whole thing. I'm just going to pinch here along that segment. I just need that midpoint right there, so that when I open up my paper, I can see the crease which locates that point right there. We are going to label that point along AB. We're going to label that as F. And it looks like our triangle is a little bit different than this one, but that's okay. We're going to label this point F. I'm going to use this pen. Now, I haven't drawn the whole median yet. I just found the midpoint. But I'm going to connect that to the vertex that is across the triangle from that. So using a straight edge, I'm going to connect point C to point F. Hopefully that drew. Nope, let me use this pen. C to F. Having pen issues. There we go. All right, so you're going to do that same fold 3 times. So now I'm going to fold point C on top of point B. And remember, I'm just going to pinch the midpoint of that side. So I just care about this point right there, so that when I open it up, I have my midpoint. And I'm going to label the midpoint along BC as point E. So now I have one more. I need to draw that median. So I'm going to connect point A to point E using a straight edge. And now I have one more median. I need to pinch the midpoint of side AC by folding point on top of point. So A on top of C. Pinch just that point right there. Open it up. And I bet you can guess we're going to label that point D. And I'm going to connect that to the vertex on the opposite side of the triangle, which is point B. Now, if you'll notice, those 3 medians intersected at a single point. So remember, they are called concurrent segments because they all intersect at a single point. The medians intersect at a point called the centroid. So you can label the centroid. Now, what I want you to do to finish out this video is you're going to measure these things that are question 10. So using your ruler, you're going to measure from point A to the centroid, and then point B to the centroid, and C to the centroid. And then from the centroid to point E, centroid to point D, centroid to point F. Now, I would suggest using the centimeter side of your ruler. That'll be easier for your measurements than using the inches side. That gets a little complicated. So use the centimeter, millimeter side of your ruler. When you have those measurements done, then you can start the second video.